All right, let's go ahead and start this car sales test. Now you were supposed to go in here, open up the test instructions. You can download this. The same with download the car sales materials.zip. And I'm just going to go ahead and open this in the folder. It's going to open up this downloads folder. I'm going to take this and I'm going to bring them in a folder I've already created. I'm going to go ahead and extract all of these materials. Here we are. I'm going to go ahead and cut these. I'm going to bring them right outside into this car sales test. And at this point, you can delete these other two folders here, the compressed one and the extracted one. So the same folder, so I can go ahead and close that one. All right. Now, with the test instructions, hopefully you already had this up and you've already read these. That would be a good starting point. This is the Excel test instructions. If you have not read this already, go ahead and read this and try this problem again. We should have two Excel files, the Excel test.xls, which we do have right here. That is our Excel file, and our ABC car listing, which we have right here. Those are both in the extract file. And these are the test instructions. It says you have 30 minutes to complete this, and you want to enter and save your answers in the first tab. And then the file 2, which is this file right here, it contains all the data for Excel question number 4, which we will get into in a minute. Let's go ahead and open up this Excel test. Here we have it. This is what our Excel test looks like. All right, let's go ahead and start with question number 1. And for question number 1 and 2, we're supposed to use this car sales data right here, according to this bolded bit right there. What is the average cost of a new car in each of the 3 years given in the car sales data? So we want the average price in 2000, the average price in 2007, the average price in 2010. Now we compute an average by getting the total number of cars sold and dividing the total amount that we sold those cars for by the total number sold. So I'm going to get the total number, and I'm going to get the total cost. And this is simple enough. You just do plus, or do this plus this plus this. Pretty straightforward. The total cost, because these are a relative reference, if we copy this cell 1 over, it'll then move all 3 of these 1 over. So you see if we copy this here, it'll then add all these up because it just moved each cell 1 to the right. And so we have the total cost divided by the total number. The same with if we drag this down, it'll bring each one of these down 1 because this is a relative reference. Can bring it down again with Control D. That is a wonderful hotkey if you're not already using it. You can bring it down Control D all the way down. Once again, copies them all the way down here. Oh, I did that wrong, didn't I? Oh, I did. Yeah. Okay. We don't just want to add these up. We need to multiply by. Okay. So the total cost, yes, the average price in 2000 is the total cost divided by the total number. But this is not how we calculate the total cost. We calculate the total cost by multiplying C3, the cost of each car, by the number of cars sold. And the same with E3, we multiply E3 by the number of cars sold. We multiply the total cost of each new Ford by the number of Fords sold. There we go. That's looking better. Okay, so that's the total cost. So we sold $620,000 worth of cars in 2000. 2007 it went up to 1.2 million. In 2010 it was at 1.8 million. And let's see how much the average cost would be. So we are going to do the total cost divided by the total number. And there we have 6395. And we can go ahead and Control D this down. A wonderful hotkey. So there we go. And that's how we would do that problem right there. Moving on to number 2. This one is a bit wordy, so I'm going to go ahead and talk it through, and if at any point you didn't get this, but you feel like you understand after I talk it through, go ahead and pause this and try it again. I highly encourage you to. If a car is not driven and is sold in the year it was manufactured, car prices are expected to rise at an annual rate of 10% since 2008 and 8% in prior years. If the year column, so this column right here, represent the model year of the car, and all these car sales numbers were from 2012, what would the average sales price be? So essentially we are going to project the cost of this car from each of these years. So in other words, in 2012, this car lot sold 23 Hondas that were made in the year 2000. That's right. And the value of these Hondas have risen 8% every year till 2008. And then after that, they rose 10% every year after that. Okay, so for this, we want the average cost per car in 2012. And this one is obviously going to be a little bit harder to calculate than the answers in number 1, where it was just easy addition, multiplication, and division. This one we're going to have to use some Excel functions. There's probably a lot of ways to do this, but this is the way I did it. It rose 10% since 2008 and 8% in prior years. So that would mean if this was in 2010, to bring it up to 2012, we would need to increase its value by 10% every year for 2 years. And if I were to do something just for this one, I would do the total cost multiplied by 1.1 to the second. Because you increase it 10%, increase it 10% again, so it's 1.1 times 1.1, and that should be the answer for that. But we have got multiple years, and I'm going to try and write a function that'll work for all 3 of these years. So I'm going to go just equal to the total cost multiplied by, and we want 10% since 2008. So because this is in 2012, the maximum number of years it can be is 4 years that we are increasing by 10% every year. So I'm going to do a maximum, or I'm going to do a minimum. That's what I'm going to do. Sometimes you got to think through which one you need to do. But I'm going to do a minimum of 2012 minus the year 2000 and 4. So if this were the year 2000, the minimum would be between 12 and 4. And the minimum would then be 4 because 4 is less than 12. Whereas if we use this for the year 2010, the minimum would be between 2012 minus 10, which is 2, and 4. And the minimum of 2 and 4 is 2, so then we would use 2 in this case. That's how this minimum function works. So we're going to multiply this by 1.1 to the minimum of 2012 minus this year, and 4. So that's the first part of it. That is the after 2008 part. And then now we need to multiply it by this very same amount. You know, it might help to put these in parentheses just for organization's sake, even though by PEMDAS we probably won't need to. And then we want to do 8% in years prior to 2008, which means we would want the maximum of 2008 minus this and 0. Because in this case for 2010, 2008 minus 2010 would be -2. And so we want 0. We don't want to decrease it and then increase it. We don't want to go back to 2008 then increase it to 2012. We just want to say this was in 2010, so we don't need to raise it for the 8%. So we're going to do a maximum here. And that's what that should be right there. So if this is right, it should go, this should result in 1, because it'll increase it 1 year's worth before 2008. So this should be equal to, I'm F9ing right now. If you F9, it'll step into a function, the part that you highlighted, it'll compute that part. Click F9, that is 1.08, which is right, that's an 8% interest for 1 year. Then for this 2012 minus A4. So 2012 minus 2007 is 5. 5 and 4. The minimum would be 4, which makes sense. We're growing 8% to 2008, and then 4 years of 10%. So if we were to step into this, that would be 4. Then 10% at 4 years is apparently 1.464. Then if we were to multiply all that out, that gives us that number that we have right there. Makes sense to me. I call that A-OK. So then the total average price in 2012, I'm going to sum together this for all of the years. So we have sold a total of 288 cars for each of these 3 years. And the average cost of these, if I'm going to alt equals, that's an auto sum. So we have sold the projected amount, or if these are car sales in 2010, we would have sold each of these for 5.7 million. And we have sold a total of 288 cars. So the total average price of this would be the 5.7 million divided by 288 cars, gives us an average price of $20,020. I hope you were able to get that. Let's move on to number 3. Okay, and here we have something that we need to recreate, an exhibit. Everything in black is just, it's a value that you hard code. You just go ahead and type that in. I've already typed this out. I'm not going to spend this whole video typing it out, so I'm just going to copy it over from this other sheet that I have. Get the widths. Right. I'm going to go ahead and wrap these. Maybe that'll make that look a little bit better. All right, so that's essentially what we've got right there. I'm going to go ahead and put a comma on there. Well, let's just get rid of the decimals. And there. So that's essentially what we have. And then we need to go ahead and recreate this part down here. So this would be 2011, 2012. At this point you can drag down and it knows just to add 1, 2013, 2014. And then we'll have the average down here. And then I'm going to go ahead and do new to 1, 1 to 2, 2 to 3, and 3 to 4. And we don't have anything for the 4 to ultimate, but we're going to keep it there just for consistency's sake. Let's go ahead and scroll back. Okay, this is the sales price by year and age. And if we sit and think about this for a second, what could this mean to get a factor of 0.8156 going from new to 1 year, when here we have a brand new and a used 1 year column. So this is how much they depreciate. So from a brand new car in 2011 cost 22,000. A car that was sold in 2011 and then it was used for a year is now worth only 18,350. And we see if this data is taken in 2015, we can't sell a car in 2015 and then use it for a year because that'd be in 2016, which would be in the future. That's why there are no numbers here. And the same with buying a car in 2014, using it for 2 years, that's why there's no number here, etc. That's why this bottom half of the triangle is not filled out. We don't have data for it yet. Now we need to go ahead, and so it looks like we are getting a depreciation factor from new to 1 year. And the way we will do that is we will divide this number, the used 1 year, by the brand new amount, 0.81555, which if we run that to 4, 0.8156. Or the way we can also do it, I'm just gonna clear this entirely. If we divide this by this, then we can round this to 4 digits. Round is an excellent function. we can get that exact number. And because these are both relative references, we can pull this function down. If you Control D, or you can use this little slidey thing right here. We'll pull that down. Same, you can pull it all the way down there. The same with from 1 to 2. We can move that function over. Use year 1 to use year 2. So after the first year, it goes down in value almost 81%. We're matching the number here. Going from used 1 year to used 2 years, it only goes down by 5%. So it retains 95% of its value from year 1 to year 2 on average. And we can go ahead and I'm just going to copy this, paste, paste, and there would be nothing to do here, so it's just going to give us 0. I'm just going to delete that. And that's exactly the numbers, as you see, we have right over here. And for the average, we are just getting the average factor across all the years. So we can get average, everything right there. The same with, you can do that right there. Because there's a blank there, it doesn't take that into account in the average. The average of all these in 0.7018 is just 0.7018. And that's how we would do that. I hope you were able to get that. Here, let's go ahead and outline that too. I'll make that look better. Give that outside borders. Beautiful. Okay, now on to number 4. We will give you an Excel file with 2 tabs, each containing a car sales listing. Yes, now this is the other attachment that we had, that we were given in our folder. If I can go and pull up, no, not that one, don't want to click on that one. If I can go and pull up the car sales, we have this ABC car sales listing. Let me go ahead and open that up. It has car sales in Detroit and car sales in Michigan. Now what I'm going to do is I'm going to bring both of these files, I just control clicked, so then I was able to click on both of them, and I'm going to move them into the other one, into the other workbook that we have. So I'm going to go ahead and bring it into the test. I'm not going to create a copy because I don't need these anymore once they're moved in. Move it right to the end. The first tab will contain Detroit sales and the second one will contain Pittsburgh sales. Yep. Please make a new tab of summary tables and comparison charts that contain the following for each city and in total. We need the number of cars sold by year of sale and include the total. We need the total price of cars sold by year of sale and include the total. We want the average price of cars sold by year of sale and include the total. And then we have to make charts for each of those. Now, the first thing that I'm going to do is I'm going to make a totals tab, because it said here that we want summary tables that contain these numbers for each city and in total. So we want comparisons for the total of both of them. Combine these two into one sheet. I'm going to do Shift F11, which will bring up a new sheet. I'm going to take this sales data from Detroit, copy that over here. Then I'm going to take this same sales data right here. I'm just going to go ahead. I'm going to copy these in. I'm going to copy the width too. Okay, so we have this long list of both Detroit and Michigan. Not Detroit or Michigan, Detroit or Pittsburgh. I'll call that combined. All right, it's going to take a bit of time to sort of recognize when you need a pivot table. When you're aggregating by something, that is the perfect time to use a pivot table. So when it says here, number of cars sold, so it wants a count of the cars sold by year of sale. If it says by year of sale, that means you're grouping by the year. And you're going to want to use a pivot table to group by. Pivot tables are really excellent and easy for that specific purpose. Pivot tables are excellent for analyzing data. We have here, I'm going to go and just make a year column right now. And I'm going to get the year of each of these, and that's going to help us in our pivot tables. So the year of February 12th, 2020, 2010 is 2010. I go ahead and I pull this down. It'll give us the year for each one of these. Oh, you know what? It would actually help a lot so that I don't need to do 3 different tables. I could just do 1 table to have the city in with this. And I didn't copy the city over to begin with, so I'm just going to go ahead and delete this. Delete all of these. Make sure there's nothing here. Copy this in. And all of these are from Detroit. Do a bottom border just for fanciness. Then right here I'm going to copy in the Pittsburgh data. Copy for, there we go. Goes all the way down just as we'd expect. These are for Pittsburgh. There we go. All right. Now I'm going to take all of this. I've got all the dates, all the sales prices, all the years, and all the cities. Okay, and I'm going to bring this into a pivot table. I know the hotkey for this, it's just Alt and V, but I'm gonna go ahead and try and find it in here so that you can see what I'm doing. Insert, here you insert a pivot table. There we go. You insert a pivot table. So I'm gonna go ahead, select a table arrange. I'm going to select all of this data. Then I'm going to put it in a new worksheet. Move this sheet over. I'm going to call it summary because it asks us to make a new tab of summary tables. So I'm just going to call it summary. Makes sense to me. And we want to see the number of cars sold by year of sale. So the number of cars sold is we want to count by year of sale. So in the rows, we want the years. In here, we want to count, which we can use any of these for a count. And we want this for each city and in total. So we can put the city in the columns and it'll group by Detroit, Pittsburgh, and it'll give us a grand total. Nice how that worked out. And then we can put the sale in here. I believe the default is sum. Yes, it is. We are going to change that value field settings to a count. We're getting the counts of all the cars sold in each of the cities. Looks like we're selling a lot of cars around this area. Didn't sell too many in 2010. All right, and we're going to do the same with total price and average price. So we're just going to go in here, make another pivot table. We could copy the last pivot table, but what's the fun in that? Existing worksheet. I'm going to put it in the same worksheet we had before. Just going to put it right next to it. I'll put it 2 over. The same with, we want the year in the rows, the city in the columns, and we want the total price. Simple enough. I'm going to go ahead and format these. So that's our counts. That's a count of sale. This is our sum, our total sales. And then I'm going to go ahead and just copy this entire thing. And then for the last one, we wanted the average price. So these are our 3 tables: the total number of sales, the total amount of sales, and the average sales price for each one. Now, what is happening in 2008? $10,000 average in Detroit. Oof, that's not very good. All right, now at this point, we're almost at the end. We just need to make charts for each one of these. We want both Detroit and Pittsburgh in the same one chart. Now for me, I can never really remember how to exactly make charts. For me, this is more of a just play with it till it looks right type of thing. And so we want a chart compare the number of cars sold by year of sale. So I'm going to go and I'm going to insert a chart. And because we are comparing the two in one chart, I'm going to use a bar graph. That feels appropriate for this. No, and stay there. That looks like a good chart. That one doesn't look very good. I guess that one could be okay, but I don't like how you can't see how the total number changes across years. It just shows you. So I think this one would be the best because it gives you the relative to each other. Red's higher than blue in 2007, but you can also see that the total number in 2007 is much greater than in 2000. So I'm going to go ahead and bring that down there. And then you can change different styles about this in the design. Let's see. Quick layout. I mean, that first one's pretty good, I think. Chart title, because as it says here, we want to format it so it's presentable. Let's go ahead and give it a title. I'm going to call it number of sales by year and city. Yep, and that looks pretty good to me. Maybe we could choose the one that gives us the numbers with it. Oh, that one's super tough to see. Nah, that one's fine. For the sake of this test, that'll do. Same with this. Let's go ahead and insert a chart for this because we want another chart for total price and average price. Let's go ahead and slap these charts in here. Insert a chart. Design, let's give it something with a title. I'm gonna go ahead and call that total revenue by year and city. And here we're gonna go ahead and insert the last one. Design it. Not format. Design. Give it something with a title. Go ahead and call it average car price by year and city. And there we go. Those are our three charts. Maybe make this one a little bigger. Number of sales, total revenue, and average car price. And that's what it asked for. All right. So that was our car test. I like this test because I based it on a test I was actually given in real life. I changed a lot of the problems to something I thought would be better for this, but it's nice. It's confirmed that this is something that you'll actually see in the real world, and it has a lot of data analysis type things, such as this is something that's really nice. The same with pivot tables. That's something you definitely need to know how to do, to where, and especially if you're going to be presenting to clients, clients love charts. So yeah, get used to making charts if you're in that type of role too. I hope you were able to get that, and I will see you in the next test.